April 21, 2026. NASA's Goddard Space Flight Center, Maryland. NASA Administrator Jared Isaacman walked up to a microphone and said something that made every astronomer on the planet stop breathing for a second. What would take Hubble 2,000 years to process, Roman can do in a year. Behind him stood a machine 42 feet tall, 14 feet wide, fully assembled, fully tested, ready, the Nancy Grace Roman Space Telescope, and in just a few months, it launches. Now here's why this matters more than almost anything else happening in science right now. We have spent decades building telescopes that zoom in, that stare deep at one tiny patch of sky. JWST is incredible, but it sees a keyhole. Roman sees the entire door. And what it's going to find in its first 5 years alone is almost impossible to comprehend. Before we get into what this telescope can do, we need to talk about who it's named after. Because this isn't just a telescope, it's a tribute. Nancy Grace Roman was NASA's very first chief of astronomy. In the 1960s, when women were barely allowed in the room, let alone leading scientific programs, she fought relentlessly for one idea, that we needed telescopes in space. She assembled the scientific committees. She built the case. She pushed through the bureaucracy. And her efforts directly led to the creation of the Hubble Space Telescope. She never saw Hubble's greatest discoveries. She passed away in 2018. But NASA named their next great observatory after her. The woman who made Hubble possible now has a telescope that makes Hubble look like a peephole. That's a legacy. Okay, let's talk about what this telescope actually does. And I'm going to give you numbers, because the numbers are the only way to understand how extraordinary this is. The mirror. Roman's primary mirror is 2.4 meters wide, same size as Hubble. So far, sounds familiar. The field of view. Here's where everything changes. Roman's camera covers a patch of sky at least 100 times larger than Hubble can see in a single image. 100 times. In one shot, NASA Administrator Isaacman said it best. Its images will be so large. There is not a screen in existence large enough to show them at full resolution. Let that settle. Not a single screen on Earth can display one full Roman image. Not an IMAX screen. Not a stadium screen. Nothing. The speed. Roman's surveying capability is 1,000 times faster than Hubble. What Hubble spends 2,000 years imaging, Roman does in 1 year. The camera. A 300.8 megapixel multi-band infrared camera. For comparison, the best professional cameras on Earth are around 100 megapixels. Roman's camera is triple that, and it's pointed at the universe. The launch. SpaceX Falcon Heavy, targeted for early September 2026, 8 months ahead of schedule and under budget. In a world where major space missions routinely run late and over budget, Roman is somehow ahead of schedule. NASA called it a true success story, and this time, they're not exaggerating. Now let's talk about what Roman is going to find. Right now, humanity has discovered approximately 6,000 exoplanets, planets orbiting other stars. 6,000 in total. After decades of searching, Roman is expected to find 100,000 more in its 5-year primary mission. Not thousands. 100,000 planets. Here's how. Roman uses two methods that work together. Method 1. Transit. When a planet passes in front of its star, it blocks a tiny fraction of the starlight. Roman monitors hundreds of millions of stars simultaneously. Its enormous field of view means it can catch these signals at a scale no telescope has ever achieved. Method 2. Gravitational microlensing. This one is based on Einstein's theory of general relativity. When one star passes in front of another from our perspective, its gravity bends and magnifies the light from the star behind it. If that foreground star has a planet orbiting it, the planet's gravity creates an additional signature in that bending light. Think of it like Einstein's magnifying glass. Microlensing is the only method that can detect planets in the habitable zone of distant stars, and even planets that don't orbit any star at all. Rogue planets. Worlds that were flung out of their solar systems billions of years ago and now drift alone through the galaxy. Roman will find thousands of them. And then there's the coronagraph, a special instrument that blocks out a star's light, like putting your thumb over a bright lamp to see the room around it, allowing Roman to directly photograph planets orbiting nearby stars. Only a handful of exoplanets have ever been directly imaged. Roman will change that permanently. Scientists at NASA say some of these planets could be Earth-sized, rocky, possibly inhabitable zones. And Roman will show us what their atmospheres are made of. We are not just counting planets anymore, we are reading them. But planets are only part of the story. The biggest mystery in all of science, and I mean that literally, is this. 95% of the universe is invisible. Everything we can see, every star, every galaxy, every planet, Every atom of matter that has ever been observed by any telescope in human history adds up to just 5% of what the universe actually contains. The other 95% is dark matter and dark energy. We know they exist because of how gravity behaves. We can see their effects, but we cannot see them directly. We don't know what they are. We don't know where they came from. And our current models of the universe, which have guided physics for decades, are starting to show cracks. NASA's senior project scientist Julie McHenry said it plainly at the April 21st news conference. Current observations hint that our standard model of the universe is incorrect. Roman is going to map 1 billion galaxies across cosmic time. It will trace how dark matter has shaped the structure of the universe, how it holds galaxies together, how it bends light, how it has driven the formation of everything we can see. And for dark energy, the mysterious force that is causing the universe to expand at an accelerating rate, Roman will find and study tens of thousands of Type Ia supernovae. These exploding stars act as cosmic measuring sticks. The more of them we measure across time, the more precisely we can understand how dark energy has changed throughout the history of the universe. These are not just academic questions. Understanding dark energy could fundamentally change our understanding of how the universe will end. Will it expand forever? Will it eventually collapse? Will it tear itself apart? Roman might tell us. Here's a number that I still can't fully process. By the end of Roman's 5-year primary mission, it is expected to generate 20,000 terabytes of data. That's 20 petabytes. If you tried to store that on standard hard drives, you'd need roughly 20. Scientists from around the world are already preparing their algorithms, their computers, their pipelines, to handle data at a scale that has never been generated by a single observatory in human history. And here's the beautiful part. All of that data becomes public. Every image, every survey, every observation, available to astronomers, universities, students, and AI systems worldwide. The discoveries Roman makes won't just come from NASA scientists. They'll come from a PhD student in Lagos who notices something strange in a survey image at 2 a.m. From an algorithm trained to detect anomalies that no human eye would catch. From collaborations between researchers on 5 continents. Roman doesn't just expand what we can see, it expands who gets to look. I have to tell you something about how Roman got here, because it almost didn't. Twice, in 2025 and again in 2026, the Trump administration attempted to cut NASA's science budget in ways that would have ended the Roman Space Telescope program entirely. The proposed cuts were deep, they were real, and they came at critical moments in the telescope's final development. Both times, Congress pushed back. Both times, the mission survived. And now, in what the Register called a rare success story in an era of government project failures, Roman is 8 months ahead of schedule and under budget. It will ship to Kennedy Space Center in June 2026 for final launch preparations. The telescope that was nearly canceled twice is about to become one of the most important scientific instruments ever built. Sometimes, the things worth fighting for actually survive. In September 2026, a SpaceX Falcon Heavy rocket will carry Roman to its final destination, a point in space 1.5 million kilometers from Earth, alongside JWST, where it will begin its 5-year mission. In those 5 years, it will find 100,000 planets. It will map 1 billion galaxies. It will stare into the dark heart of our Milky Way and reveal things that have never been seen. It will collect data that scientists will still be analyzing in 2050. Hubble showed us the universe is beautiful. JWST showed us the universe is ancient. Roman is going to show us the universe is full of planets, full of dark structure, full of mystery waiting to be named. We are one rocket launch away from the biggest atlas of the cosmos ever created. September 2026. Watch the sky.